Hey guys, I'm back and this is the video for Thursday, March the 19th, and today we're going to be talking about power. So last couple of days we've talked about work, and that work is force times distance, and now we're going to be talking about something called power that depends on how much work is being done and how quickly that work is being done. So if you will get on Google Classroom and click on the link for the Nearpod for under today's assignment, NTI, I think it's NTI Day 10. Okay, you click on the link for NTI Day 10 on the Nearpod and it will take you to the Nearpod and where you need to be to take the notes for power. So there is a note sheet that is attached to the Google Classroom assignment. If you want to print that out, you can. If not, you can jot all these notes down on your own paper. And again, they'll always be on Google Classroom through this link if you need to go back and look at something. So it's important that you go ahead and slide on over to slide 7. The first 6 slides are just a review of work and a quiz about work. You do not have to do those. That is totally up to you if you want to do more practice with those. But we're going to talk about power right now. So power is the rate at which work is done. Okay? It's how much work is done and how quickly the work is done. It's also known as the rate at which energy is transferred. Okay? So that is the first slide that you're going to see on... I can't flip my camera around, but that's the first slide that you're going to see on Nearpod is the definition of power. Okay, if you click on over to the next slide, it gives you the equation. The equation for power is work divided by time. Okay, so work in joules divided by the time in seconds. Okay, gives you power. The next slide over is talking about the units. Okay, the units for power are in watts. Okay, just like the light bulb, watts. That is a joule per second. Joule per second. Okay, so work over time is joules per second. And that gives you the unit for power, which is in watts. Okay. So, we'll go ahead and do some practice problems real quick about power. And these are the ones that are on the Nearpod, and they're also on your note sheet. It says, if 4,500 joules of work are done to lift an object in 5 seconds, what is the power? Okay, so let me erase this off the board. Okay, so power is equal to work divided by time. All right, so if we have 4,500 joules and they're doing that amount of work in 5 seconds, that's how I set my problem up. 4,500 divided by 5. Okay, punch that in my calculator. It is 900 watts. Okay, 900 watts. Now, I don't abbreviate watts with a capital W just because that's what we use for work. Okay, and I don't want y'all to get confused with that. So, every time that I write out the units for watts, I'm spelling out the entire word. as not to get confused with this W up here, okay? So, let's go on to the next slide. And the next problem, it says, a tired squirrel, mass of approximately 1 kilogram, does push-ups by applying a force to elevate its center of mass by 5 centimeters in order to do a mere 0.5 joule of work. If the tired squirrel does all this work in 2 seconds, I can't read the rest of the problem. Oh, if he does all this work, or she, could be a she, in 2 seconds, then determine its power. So, it gives us 4 different values in this problem. So we're going to have to identify which ones we need for our equation. So, we do have 1 kilogram, which is a mass that we should know that. It gives us 5 centimeters. That's a distance, okay? It gives us 0.5 joules of work, and then it gives us 2 seconds, okay? So we are determining power. For power, we only need work and time, okay? So, we will not use all 4 of those values. We will just use work in joules, okay? So, 0.5 joules divided by the time, 2 seconds. So, 0.5 divided by 2 is 0.25 watts. Okay, 0.25 watts. I'm sorry, my writing is very sloppy, but I will try to do better next time. Okay. Next question. And last question or example. When doing a chin-up, a physics student lifts her 42 kilogram body a distance of 0.25 meters in 2 seconds. What is the power delivered by the student's biceps? Okay. So, we have a mass, 42 kilograms. We have a distance of 0.25 meters. And we have the time of 2 seconds. So we have to calculate power. And to calculate power, we know we have to have work and time. But in this problem, we're not given work. So we're going to have to figure out the amount of work being done. And in order to do that, we have to figure out 2 things. Or we have to figure out one thing, because the other thing is given to us. We have to figure out force, and the other thing that's given to us is the distance. Okay, so it's given us 0.25 meters as our distance, but it doesn't give us the force to figure out work. So this is actually a 3-step problem where we're going to have to figure out force first, then we're going to have to calculate work, then we're going to have to calculate power. Okay, so force is first. Newton's second law says that force is equal to mass times acceleration. Okay, so our mass is 42 kilograms. Our acceleration, if we are not given an acceleration, we are assuming that we're using the acceleration due to gravity, which is 9.8 meters per second squared. That's where that comes from. Okay. So if we multiply those two numbers together, 42 times 9.8. That gives me a force of 411.6 newtons. Okay. Now, the second step we said was to figure out the amount of work being done. Okay. Work is equal to force times distance. Okay. So we are going to take the force that we calculated in the beginning and put it in our work equation. Okay. So 411.6 newtons times our distance, which was given in the problem, 0.25 meters. Okay. Now I can multiply those two numbers in my calculator, and that gives me 102.9 joules. 102.9 joules. Okay. Alright, so I'm running out of room, so I'm going to have to erase all of this. So if you need to pause, you can go ahead and pause to get this down on your note sheet. But I will go ahead and erase that, and we will go on to the next step. So the final step in this problem is to calculate power. So power is work divided by time. Now I'm going to take the work that we calculated just a minute ago, which was 102.9 joules, and divide it by the time that we were given in the problem, which is 2 seconds. Okay. So punch that in the calculator, and that gives me 51.45 or 51.5 watts. Okay, so we just completed our first 3-step problem, and if you didn't understand it, go back, rewind the video, watch it again. If you still don't understand it, contact me, shoot me an email, message me on Google Classroom, and I will try my best to clarify all of this with you. Okay, tomorrow you will have some practice problems over power. Okay, there's also a triangle for power. You can go ahead and write this down on your note sheet as well for tomorrow. Okay, so for power, you have work and time, but work goes on the top of the triangle. Power and time go on the bottom. Okay, so if you're given a problem where you have to calculate time, you cover up time, it is work divided by power. If you're asked to calculate work, cover it up, it is power times time. Okay, so I would jot that down on my paper, on my note sheet, just in case you need that for tomorrow's assignment. Okay, now the practice problems, if you want to take a picture of those and send those to me through email, I will take a look at those. I'll also make another video on Friday going over those problems with you. Okay, so we will have a quiz over work and power probably on Monday, so be prepared for that. If you have any questions, let me know before then, okay? That will probably be through a Google form similar to the thing that I made you all transfer your answers over for the summative this week. Okay, so if you haven't done that yet, you need to do that right now. You need to do that. That is due tomorrow. That is due by Friday. Make sure you get your summative answers that you took the summative on Monday. Get those transferred over to the electronic answer sheet so that I can give you your grade on Infinite Campus. Okay? That's all I have for today. So I will see you guys tomorrow. Take care.